Okay, we're on page 5 of your 1844 notes. We talked about, given this equation, generate the ordered pair of x equals 4, and we had to solve for y to figure out that y coordinate to give us our point 4, 5. And I asked, why would this take some time if we had to do it for the domain? And Ms. Sanchez correctly said, because we have to do it over and over and over again. We have to solve this equation every single time to generate these points. And sometimes that's easy, but sometimes it just is annoying, and I don't want to do it. Okay? So what we can do instead is manipulate this equation so that it's easy to work with. What is a form of an equation that's easy to generate points? Like, just give me an x and you can easily give me a y. Would this form be easy to work with? No. Because we have to do it over and over again to solve for y. Okay? But what's like another form that's like easier to figure out the points? Like, what's going to be easier? This guy or this guy? The first one. But why? Why is that one easier? Besides that it has just less stuff in it. Any ideas? It has less steps. That's one. But I'll look at this guy right here. I know this guy is going to be easier to work with than this guy. Why? Ms. Cordova? Yes, because the y is by itself on the other side of the equation. And all we have to do is plug in x's and we'll get the y's easily. We don't have to solve anything. We just have to like simplify stuff. Okay? Boom, got my y. 6. Okay? So what we can do with equations like this is we can solve them for y to easily generate solutions. Okay? And if you have space, and I'm sure a lot of you do, let's do that over here. How do I solve this for y? Goes back to chapter 2. What's the first step? Mr. Jacoby, what's the first step? No, I'm not plugging in anything. I just want to get y by itself before I plug in stuff. So how do I get y by itself with this equation? Good. I would add positive x. So this goes back to, hey, here's my princess, y. What's bothering it? The 2 and the negative x. What is the 2 doing to it? It's multiplying. What is the negative x doing? It's adding to it. So to get rid of those things, we get rid of the stuff being added first by adding the opposite. Okay? We'd have 6 plus x. And then we would divide both sides by 2. And I'd get y by myself. Y is equal to 6 plus x divided by 2. However, we're going to do one extra step now. Okay? We are going to divide both of these pieces by this 2, and I'm going to split it up into 2 different terms. So 6 divided by 2, I know is 3, plus x divided by 2. Well, I know that's 1 x divided by 2. 1 divided by 2 is just 0.5 times x, or 1/2 times x. Okay? Now, I can plug in -4, -2, 0, 2, and 4, and I'll be able to get my y's easily. Also, I'll discover today, and you'll discover today, that you're going to be able to use your calculator to generate solutions easily. Okay? And we're going to do that in just a second. So let's go to the last page, and let's first practice this. Let's solve these equations for y just so that we can generate solutions easier than if it was just like this. Okay? So we already did the first one. I'd add my x to both sides. Now, another thing that I'm going to want you to do is actually put the x first and the number next to it, which is why it's important to make sure we're adding the opposite, because this is not going to work if we're doing subtraction. So if I add x to 6, it's 6 plus x, or x plus 6. And then I divide both sides by 2, and I will split up my fraction into 2 pieces. I'll have like 1/2, or 0.5x, plus 6 divided by 2 is 3. And this is my equation that's going to be easy to generate solutions from. Okay, you guys do the next one. Check your answers with the neighbor when you're done. Now, subtract all of those x's, Mr. Rodriguez. All 4 x's. Subtract. You can't just subtract the x away from it. You're going to want to move all of those x's. You're solving for y. Identify where y is, what is bothering y. Remove the stuff being added first. Remove the stuff being multiplied last. You should have y is equal to something x plus something. Make sure we are dividing by -2, not just 2. We remember properties of subtraction. I can turn this subtraction into add the opposite, and I'm going to want to do that. All right, check your answers with the neighbor. I don't see anybody checking. Let's go. Check. Help each other out. Ms. Cordova, turn around and check. Mr. Victoria got it, I think. So, Mr. Victoria, you got -2x. What's the difference between yours and hers? Don't subtract negatives. Add positives. Add -4x to start. I want you to write -2y is equal to -4x plus 6. Get your x in front. Okay, this is why we're adding. We can do this if we're adding the opposite. Then divide both sides by -2. Dividing -4 by -2 gives you positive 2x. Dividing 6 by -2 gives you -3. Okay? And this is how I want your answer. If you don't have it like this, make it like this. Okay, do the next one. Where's y? What's bothering y? Remove the stuff bothering by adding the opposite first, and then by dividing last. Check your answers with a neighbor. Mr. Moeller, first step.
Add negative 12x.
Beautiful. Mr. Moan, second step.
Divide both sides by negative 3.
Beautiful. And Mr. Orsic, what's the last step?
It's 4x plus negative 2.
Good. Divide the pieces by the negative 3. Okay. Notice how we're taking care of positives and negatives. We're not screwing things up. Okay. Last one's easy. What do you have to do, Mr. Smith? Not just x. Negative x. It would be negative x plus 6. Okay? Probably wondering, why are we doing this, Mr. Messner? I can still just find points by plugging in random x's and finding the y's. Well, there's a big reason why. This is your calculator. This is called a graphing calculator. You guys ever hear this being called a graphing calculator? What do you think that means it can do, Mr. Cummings? It can graph. Turns out your calculator is a solution generating machine. You can plug in stuff into it and it will tell you a bunch of solutions just like that. I have notes for you guys so that we can kind of write down how we actually graph. I just need to find them. Here they are. Now, the front is getting to know the basics of your TI-84 calculator. You guys know pretty much all these buttons here. We're going to do notes on the back, though. And when we're done, you guys were going to be all mad at me because knowing what you'll know after today would have made your homework over the weekend a lot easier. But it'll be okay. Okay, so you probably know all of this stuff already. I'll close this so we can see more. We know how to turn on the calculator. We should know how to turn off the calculator. You press second, then the on button. That's off. We should know that the second button allows you to access the stuff in blue. So if I press second, then this like SIN button, you see the thing in blue above it, SIN with a -1. If I press second and this, I get a square root. Okay, so second and then a button, you get the stuff in blue. Well, the green button actually will access the stuff in green. So all these letters. So where is T? I can't even read. So you have to press alpha each time if you want to do this. But you can, write stuff down. These are letters. Space is down here. Okay, so you can write little notes. Now, if you don't want to press alpha every time, you can go second alpha, and you get alpha lock. This is A lock. And then you can just keep pressing your buttons without having to press alpha every single time. Okay, so that's alpha. You don't use that often, but it's there. Let's see. We have an apps on our calculator. We won't use that much, but there are some programs usually in your calculator. Maybe we'll use it every once in a while. If you ever want to get out of something, say you accidentally pressed like table or something like that, or trace, and you want to go back to the home screen, you go second quit. Okay? And the most important thing that you should know is how to reset your calculator. So to reset your calculator, and I want everybody to do this, you're going to press second plus 7, 1, 2. Okay, so go press second plus 7, 1, 2, and reset your calculator. Okay, everybody, go ahead, reset your calculator. Second plus 7, 1, 2. Should have this screen, it should say RAM cleared, and then you just press the button and it clears it. All right. Well, on the top, we have these buttons that we haven't used yet. Y equals, Windows, Zoom, Trace, Graph. These are going to be your graphing buttons. Okay, so let's flip on the back and let's take some notes on how to graph with your calculator. Okay. First button you need to familiarize yourself with is this Y equals button. Okay. Y equals is where you plug in equations. Okay, so notice how it says Y equals. Your calculator is powerful, but it's not extremely powerful. Your calculator will only graph equations that have a Y equals format. So all of those, and I shouldn't have closed them, but all of those equations that we saw on the last page of our notes, you would not have been able to plug in negative x plus 2y equals 6, and your calculator would graph that. Your calculator forces you to solve for y and plug in 1/2 x plus 3. Okay? So make a note of that. Calculator can only graph y equals stuff, equations. Okay? Let's go ahead and in our y equals, let's graph that last equation, the 1/2 x plus 3. I can type in to my y equals that equation, 1/2 in parentheses. Okay. Now I have to get an x. 2 ways to get an x. Who knows one way to get an x? This page? Yeah, you go to your letters. You go alpha and x is where? There? Yeah. The store button. Okay, so that's one way to do it. The other way to do it, it's actually a quicker way, is this button right here next to alpha. It is a shortcut X button. See that? So we will type in 1/2 X plus 3. Okay? Well, typically we will press the graph button next. The graph button will show you your collection of solutions and what it looks like. It'll show you the collection of solutions. Or what does your graph look like? All right. So once you've entered in your equation, you press graph, boom, you'll see the graph. So go do that. What's it look like, Ms. Tristan? What's that look like? Just a line, exactly. My collection of all my solutions looks like a line. Well, that's cool and all. However, I can't really see exact solutions, right? Like, it's tough. We have little markers, and each of these are 1 each, but it's tough to kind of like see exactly where those solutions are. Well, there's 2 things we can do. We can either enter in values. Maybe not. I have to go do set value or something. We could press the trace button. Okay? So trace will kind of follow along your graph. And it'll show you solutions. However, some calculators, it'll show you decimal solutions, which is not nice. Some calculators, it'll show you very nice, like, whole number solutions, which is better. But at least you can see where your graph is, and maybe you have an idea of some solutions, okay? So trace shows you decimal solutions. And I would call them crazy decimal solutions. I believe if you press trace, now you can enter in a number. Yes. And it'll get you extra points. Okay? So once you press trace, you can plug in numbers. So that's a great way. Say you want to know what is the y that goes with 4. Once you press trace, you can press 4. It says x equals 4. Press enter. It says 4 goes with 5. That is a solution for 5. So everybody find the solution that goes with negative 7.2. Go. Mr. Stalker. Press trace and then plug in the number. Does everybody get it? I want to see everybody's calculator on the point 7.2 and whatever goes with it. Nice. 7.2. Yep. Beautiful. See how I can, no, press trace. Now type in 7.2. Press trace. Now press 7.2. Enter. There you go. You did not type in your thing correctly. So we want the graph of 1/2 x plus 3. That's the graph. Now press trace and 7.2. Good. We should see 6.6 even. No. So we are graphing this. So we don't want 7.2 here. We want this equation, 1/2 x plus 3. Okay. Now trace and 7.2. There you go. Cool. So that's one way to find values really quickly. Another way to see a bunch of different solutions is with the button table. Shows you a bunch of solutions. So, table is above graph. To access it, it's in blue. We have to press the second button and then the table. Everybody pop up the table. Those points are all solutions to that equation. So that's table set. You want table up there. Okay, cool. So you can move around and find, 5 points really quickly. So on your homework, you could have plugged the equation in, press graph, go to table, find a couple points, plot those points so that your graph looks nice and it's actually specific, and you're good to go. So if I asked you to graph y equals 1/2 x plus 3, you would not just go ahead and on a coordinate plane sketch something. Be like, oh, it looks like this. No, that is not going to fly. We have the capabilities of getting specific solutions using these different methods, whether it's our table or using our trace and entering in x values. Okay? I want you guys to plot specific solutions like 0, 3 on your graph and make sure that your graph is exact, just like you would if you didn't have this capability. -4, 1. Four, 5. Okay. If you have 3, maybe more, you have a nice looking graph. Must find specific solutions. Okay. I want you guys to graph y equals absolute value of x plus 2 minus 3. Go. I'd clear out this y equals, and I need to type in the absolute value of x plus 2 minus 3. How do I get to the absolute value? Who remembers? Do you remember, Mr. Orsick? No? Does anybody remember? How do you pull up absolute value? Sarah, do you remember? No? Anybody? Math. Over to number. ABS. That's math. Go to the right to number. Press enter. And you either get ABS or you get the absolute value symbol. Now this is interesting. I'm inside the absolute value symbol. How do I get out? Got to press right to get out of it. Okay, everybody graph it. Go. X plus 2 in the absolute value minus 3. Perfect. Now, I want you to plot it on your paper, so what do you have to do? Get specific points, plot them, make sure your graph looks just like it did. What is that? That looks great. Oh, x times x plus 2 minus 3. Interesting. That's it right there. Let me see your trace. Does your trace come out as nice decimals? No. But you could still do that. Good. Go. Give me 3 solutions at least. 5, if you feel up for it. How do you get the solutions, Mr. Stalker?
Second graph.
Yeah, we can go to table. What's another way to get solutions, Mr. Miller? Besides the table, how can you get solutions? Yeah, well, we can graph. We're definitely going to want to graph. One way to get solutions is to go to second table. These are solutions, but what's the other way? Yes, trace, and then we can enter in different values. Make sure it looks like a V too. The graph that you graph should look just like the graph you see on the screen. Math to the right. There it is. X plus 2, close the parentheses, minus 3. Okay. Now, back in y equals, we can graph multiple graphs at the same time. Let's say x squared. Okay? You can plug in as many graphs as you want, and they'll just plot them. This is a great way to compare graphs and what they look like. Okay? However, you're probably going to be confused as which one is which. So what you can do is go over here to the left. Watch what I do. See, I'm over here next to y2, and it's highlighting this line. If I press enter, it'll change the line width. Or I could press enter a couple more times, and it'll shade. This is another shade. This is, it'll show my line with a circle so that I can definitely tell what it is. And that way when I graph, I know that's x squared. I entered in an equation wrong. It should be negative 3x. If you ever get a syntax error like this, most likely, first press go to, most likely you have a subtraction sign instead of a negative sign. Okay, so syntax errors are most likely subtraction instead of negative. So now I'll get my third one, and there's my third one getting plotted with that circle. Okay, pretty cool. I could go to my table, and it'll show me all three y's to go with this one x. So this would be the solution for my first one, negative 2, negative 3. For my second graph, negative 2, 4, that would be for x squared. My last one, negative 2, 6, that would be for negative 3x. Okay? So right now, I want you guys to play around, and I want you to try to generate the craziest graph possible on your calculator by entering crazy equations into y equals. And we will share and compare some of our crazy graphs. That way we can know the capabilities of our calculator, what it can do, what it can't do. I'll do something too. Anybody got anything? I can make a circle. You want to see a circle? Doesn't look like a circle, but it is. Because the graph is stretched. There's 10 units that go right here. There's 10 units that go right here. So since there's more space to go over there, it looks more like an ellipse. That's how you get a circle. Anybody see anything interesting? Mr. Gibson, I like your shading. That's pretty cool. What do you have? X and negative X? I like it. Mr. Gibson put this up. This is impressive. We got y equals x. We got y equals negative x. And then he shaded this one, down here, and this one he shaded up. Pretty neat. Okay. Anybody else? What do you got, Mr. Stalker?
I never did pi.
Yes, you did. How did you do that?
I have no idea.
You did some x squared ones, right?
Yeah.
What's that one up here? X to the negative 1 squared, I believe.
Yeah.
So you did x to the negative first squared. And that gives you this thing that looks like that. Actually kind of weird. Anybody graph 1 over x? Actually, probably like 4 over x is better. Looks like that. That's neat. X squareds are pretty cool. If we haven't looked at x squareds yet. X squared is when you have a u. Okay, we'll be dealing a lot with these u's and these lines this year. Anybody press buttons that they didn't even know? Come up with crazy stuff? Watch what happens if you plug in the sine of x. Sine is a trig function. You get a wavy line. And if you did like sine x plus 1, you can start stacking wavy lines. Pretty cool. Let's go to the zoom button. Anybody see the zoom button? Mess around with that. You can zoom in, zoom out into your equations if you wish. Whenever you press zoom in, you just have to press enter twice. Now you can see maybe stuff a little bit nicer. Okay? You could press zoom box, and I believe, and press enter after you press it. Oh, didn't work. Zoom decimal, I believe that's the one that makes the trace work nicely. Let's see. So press trace, and we should go by decimals. Yeah, that's nice right there. Zoom decimal. Okay, and whenever you're like, all right, I need to go back to the regular zoom, zoom standard 6 will take you back to the regular default zoom. So write that down if you don't know that yet. Okay, if you ever want to change your window to be like specific values, you go to window and you can set it, you know, between maybe -1 and 1. That would be your x's, and then your y's can be like -1 and 1, and it'll just like zoom in. It'll be like very narrow window. Okay, but if you don't like that, you just go back to zoom standard. What else? Want to know anything else? Log. Let's clear this out. I'm going to reset. If you ever want to just quickly just clear things, usually the quickest way. Log x is also like a number to the x power. That's log x. This is a number to the x. Pretty cool, pretty powerful. It's not like some of the programs you can do online though, which is why it's a great tool, but it's not the be all end all. Here's our circle in another form of the equation. I'll show you that. I show you guys a sphere. You have to add in the z. And I typed your names in. That was good. Yeah, I moved that. Okay, cool. So, interesting stuff. Anybody have any questions about using the calculator? Would this have made your homework easier? Mr. Miller, what do you think? Yeah? If I asked you to graph f of x is equal to 2x, can you do that? No? Or could you? What would you have to do? Yeah, exactly. So if you're asked to graph this, well, you just graph y equals 2x in your calculator, and your y equals, you plug in 2x. Graph, boom, there's 2x. What do you notice if I change this 2 to like a 1? What happens to my graph? I change it to a 3 and a 4. Somebody tell me. There's x. There's another one. There's another one. What's my graph doing? The R word. Anybody? You guys are awake today, Monday morning. It's rotating. I change the number before x. The lines rotate. Okay. Well, let's change that and see what happens if I change the number being added to x. What if I did x and then x plus 1 and then x plus 2? Ms. Aaron, tell me what happens. So you think it slides? You're right. So if I add numbers to x, my solutions slide. You can say it's sliding to the left or it's sliding up. Typically we say it's sliding up. Interesting? Any questions? All right. Well, we're not going to do a quiz today. Your quiz is kind of like a take-home, part of your homework, and you have a homework packet. So what we're going to do is just start on our homework, because it's a little bit longer than normal homework assignment. And then we will have a review quiz next class. We have a test on Friday in this class. So Wednesday is a review day. We will go over the review. You'll take a review quiz. Friday is a test. When you get your packet, go ahead and just go to the second page and cross it off. And you will do this as well for homework. You can cross off quiz and you can put homework. For some reason, it took me longer to get through that with the other class. But that's okay. So don't do the second page of the packet. Cross off quiz here. Replace it with homework. There you go.